All right, hello everyone. This is the OSS team, October week 3. We have a short demo this week. First, we have Jake showing us some Prometheus work.
All right, hello everyone. So let's start presenting. Can everyone see my screen? There should be a site cannot be reached page.
Yep.
All right, so what I'm going to demo today is how to combine ticking time data into basically alert data that from Prometheus that can come at an arbitrary time. So I'm going to start up my app right now. And what this is doing is this is going to be running two things at once. This is going to be running a Python Flask server, which will accept webhooks from Prometheus. And then it's running a Python script in Deephaven application mode, which is just pulling data. So it should be started up. So if I refresh this page. All right. And okay, so we're pulling in data. So this is just a simple query, simple values I have set up. And what I've done is I have set up an alert with Prometheus, which will send an alert whenever this value is over 30 million, I think is the number I set it to. So this is just pulling data every quarter of a second. So if I go to this table, and I see I have some alerts coming in, some alerts being fired, and some alerts being resolved. So what's happening right now is Prometheus is sending a webhook every time one of these alerts is either being fired or resolved. And the Flask server is deserializing that and storing it in Deephaven. So the problem with that is it's kind of hard to know, like the data coming from Prometheus is kind of hard to map to an actual value that you're looking at. So what I've done is I've taken these two tables right here, I've combined them on the job that is Prometheus is sending, the instance that Prometheus is sending, and roughly when the time is being recorded from Prometheus. So Prometheus sends a timestamp with the alerts in the webhook and also includes a similar timestamp from the API. Now, the problem with that is, since we're pulling data on a timed cadence, we don't have an exact metric, or we don't have an exact match of what the webhook data is going to be, because that can just be at any time. There's no guarantee it's going to match on the quarter second since I've started running this app. But thankfully with Deephaven, we can use lower bin to kind of group these times together and get a rough estimate of when the alert was fired versus what the metric was that we recorded. So once we get this data, we floor our timestamps, we format it and put it what we want, we join it together, and let's try that again. And so now we have a table of the data combined together. So if we look at just this first one, so it says status was resolved at this time was when we received it. This time was when was what Prometheus recorded after we bucketed it, and this was the value. So since I said that 30 million was the value that we're looking at, this being under 30 million makes sense. And then the next one firing above 30 million, and so on. And then just for my own interest, I was curious to see how long Prometheus was taking to send these webhooks. And so I added just one more column to see the delay. So this one was a half-second delay, which is reasonable. Some of these were a bit longer, 2, 3, 4 seconds. But yeah, so that's how you can combine time series data using lower bin.
All right.
Any
Cool.
questions?
All right. Cool.
All right, thank you.
Yeah. Thanks. Thank you, Jacob. All right. Next, we have Devin with a demo.
Hey, can everybody hear me and see my screen?
Yep.
Great. If you saw the video from last week, this is going to be very similar, but hopefully a bit less verbose. Last week we had a way to get subscriptions, full Barrage subscriptions, and this week I've introduced a URI format to go ahead and do that in a single line. So I'm calling this a resolution. You can resolve a URI into a table. So here is, two separate hosts that are hosting Deephaven tables. And then here is a join query that will bring it all together. Just to mention quickly, I do want to talk about URIs quickly. Here's the general structure of a URI. It's a generalization on top of a URL. So even though this example here is a URL, we can define our own URIs, and that's what I've done right here. So we're basically saying this is the Deephaven protocol over plain text. Here's the host, and here's some path information. Eventually, we can define other URIs and pull other stuff. So here again, there's the same tables that we saw last week, still ticking, and here it is joined together locally. So the other scheme that I've introduced here is for grabbing global scope tickets and application tickets. And this is something we weren't able to do before. Actually, you could grab global scope tickets just by setting a variable name here, but you can also get it through the resolve method too. And for scope stuff, the scheme is scope. And for application stuff, the scheme is called app and has a format that looks something like this. This stuff is still in PR for review, so the exact formats may change a little bit, but we can go ahead and run these, and we can see that we are resolving. Here's two different tables. Here's when our application started, and here's the current time right here, and these were defined in an application. I've also got another scheme that we've defined here, and that's CSVs. Of course, you can use CSV tools and use the CSV options to choose exactly how you want to parse stuff. But we could do it through this URI resolver as well. So I can say I want my scheme to be CSV plus file. And again, this is something we've defined or I've defined, and it's up for review right now. So we can execute these or do CSV plus HTTPS and resolve both of them. And hopefully, there we go. So there's a CSV file from HTTP, and here is a local CSV file that we've pulled in. Of course, when you're going through a resolution like this, you don't have any of your options. So this is really meant to be something that's shareable and doesn't need many more configuration options. And then the final example here is we could define a scheme for Parquet and load Parquet files up. And again, it looks like that. And, you know, the whole goal with this is to potentially be able to create single shareable strings and a single function endpoint where we can resolve from a variety of different underlying formats.
All right. Any
So
questions
is
for
the
Devin?
intention here to have also like a Parquet URL, or is that not really?
Well, we had a Parquet URI here, and this
Right.
is something that we're defining locally. If you're asking if we can do like an HTTPS Parquet file,
Right.
that's kind of antithetical to Parquet because Parquet data is supposed to be local. Of course, we could have a scheme where we went and downloaded Parquet data onto the file system and then read it from the file system. But I think you could probably use other tools to potentially do that first. So
people do pull Parquet data from S3. I mean, not that we can support it or anything like that yet, but
sure, yeah, we could do, you know, like Parquet plus S3, and that could be a scheme that we define and have support for. But this is just kind of an exploratory thing for the formats that we kind of already have easy access to. So,
All right.
beautiful work.
Well, that's it for the demo. So we'll see you next week. Bye.
Bye, everyone.